in this question, given that the each of the following functions is defined for a domain of -2 to 3, and we need to figure out what is the range of these functions. And this is same as writing f of x for part 1. That is same as writing f of x is equals to 2 minus 3x. And clearly this is a linear function. And linear function, it would just keep on increasing or decreasing. So in that case, if I talk about when x is minus 2, what is the possible values of function, which is y? So whenever I talk about the range of any function, that is the possible values of the y coordinate. So in that case, when you substitute x as minus 2, the possible values of function is, so f of x is equals to 2 minus of 3 times minus 2. So which is nothing but I'll be getting 2 plus 6, which is 8. And similarly, when we substitute x as 3, so that will be when x is 3, the value of the y coordinate would be f of x is equals to, this is going to be 2 minus 3 times 3, which is nothing but 2 minus 9, which is minus 7. So now, if you observe this, this is going to be a linear graph. And the graph would roughly look something like this. When x is minus 2, it's some positive 8 value, positive 8, so something like this. And when x is 3, it's some negative 7. So that is the reason. So the maximum possible values of y in this case is positive 8, and the minimum value of the y in this case is minus 7. So that is the reason the range for part 1 has to be where f of x will be between minus 7 to positive 8. So this is the right answer for part 1. Now, if I talk about part 2, so in part 2, basically we will be talking about the absolute value. See, the absolute value means the result of any absolute function would be always positive. So that means the graph is going to roughly looks like this. So in this case, if this is my xy plane, at minus 2, if it is 8, and at positive 7, or at positive 3, if it is 3, the graph is going to, so whatever the graph we have it in the negative region, that would be reflected back. So in that case, the graph would roughly look something like this. So instead of minus 7, so we will be having positive 7, and there will never be any y coordinate below 0. So that is the reason the range of this function where g of x is equals to mod of 2 minus 3x has to be between 0 to 8 for this given domain. And next, if I talk about part 3, so part 3, whenever I talk about mod of 3x between this, so that means, so for mod of 3x, when x is, the lowest value would be 0 itself. So when x is 0, it would be 0. But the highest value is when x is 3, you can get 9. Positive 9, of course. And when x is minus 2 or something, so it would be absolute value of 3 times minus 2, which is nothing but negative 6. So absolute value of negative 6 is positive 6, but positive 6 lies in this range. So that's why I have written 0 to 9. And since I have this negative, so I need to get this exact expression here. So for that one, so what I'll do is I will multiply with negative throughout my inequality. So when I do that, so this is going to be 0 is less than or equals to mod of 3x. I can also write it like this. Or mod of 3x is less than or equals to 9. And when I multiply with negative, the inequality would switch. So in this case, it will become 0 is greater than or equals to minus of mod of 3x, or in this case, it was going to be minus of mod of 3x would be greater than or equals to 9. And also I'm going to add 2 on both the sides. When I add 2 on both the sides, so the left hand side it would be 2, and here it would be 2 minus absolute value of minus 3x, or here when you add 2, so it's going to be 2 minus absolute value of minus 3x must be greater than or equals to 11. See, in this case, this is not at all possible. The reason why this is not at all possible is, if you talk about any absolute value function, so this is going to be always positive, and I have 2 minus some number will never ever be greater than or equals to 11, because this is going to be positive number. So 2 minus some positive number will never ever be greater than or equals to 11. So that's why this will not satisfy. But here we are talking about this 2 minus absolute value of 3x will be less than or equals to 2. So it could be any value. So if I talk about between minus 2 to 3, and when you substitute minus 2, so we will be getting 2 minus of 6. So which is nothing but minus 4 is the lowest value. So we cannot get any values beyond this. Or when you put 3 here, so it's 2 minus 9. So 2 minus 9 is nothing but minus 7. So minus 7 is the lowest value we can get, and positive 2 is the highest value we can get it. So when x is 0. So that is the reason the range of this part, the third function, which is 2 minus absolute value of 3x, will be between minus 7 to positive 2. So this is the right answer for this sum. And finally, we are talking about state which of these is an inverse function. So whenever we talk about a function has to be inverse, then there must exist, then it should be a one-to-one function. Whenever it's a one-to-one function, we say that function will have an inverse. And clearly, the first one is a one-to-one function, and the second one is not. The reason why I would say second one is not is, so this doesn't pass the horizontal line test. So that means for one y coordinate, we have two possible values of x. So suppose if y is this value, so we have two possible values of x. So that means two different values of x will give us the same output. So that one we don't say it's a one-to-one function. And the same case goes with part 3 as well. So this one will also be this one is not going to be a one-to-one function as well. So that's why only for the function f, the inverse exists. That is the right answer for this sum.